Right, we're going to begin looking at the conclusion that we can make now. We've made some statements about our sample data. We've compared our two sets, our two samples and various features of them. So now it's time to make a conclusion about what that tells us about the population. So you could pause and have a read of this page here. Notice it talks about there being three different things we comment on in the conclusion. So at the moment we're just concentrating on the first one, answering your question, making a claim whether there is a significant difference or not between your populations. And to do that we use something called the median outside the box rule. And to better understand that, if we go into the page called Making the Call, this here explains about what happens. When making a call, the decision to make a call that one is bigger than the other, back in the populations, is clear if the shift is big enough. What we mean by that is the shift is big enough if there is no overlap of the boxes. So you can imagine the graph might look like that, and then obviously it's very easy to claim that B is significantly bigger than A back in the population, whatever it is you're comparing. So that's one situation, and that's clear. And also the shift is big enough if at least one of the medians is outside the overlap, meaning outside the boxes. So if we have a look at something like this, as long as one of the medians is outside the box of the other, then we can claim that it's likely there is a significant difference and that B is higher than A back in the population. So the rule is either both outside or at least one outside, then we can claim there is. So what happens if both medians are within the overlap? So that would mean both medians are inside each other's boxes where the overlap happens. Then we've found that it's possible that if we took different samples, that actually the medians will swap around, and your teacher might show you an example of that happening, all the different possible medians, but we can't claim a significant difference if the medians are inside each other's boxes. It's too close to make a call about whether B tends to be bigger than A or not. So for a simple test, if the median of one of the samples lies outside the box for the other, we can make the call that B tends to be bigger than A back in the populations. And here's the animation that your teacher might show you. Right, so if we go back to what's written here on this conclusion 1 page, here are the three different examples. So the first one, we can see that the median for the girls is outside the box of the other, or outside the overlap. So therefore we can claim that there is a significant difference between the heights of Year 9 boys and girls back in the population that this sample data came from, and we'd conclude that girls are taller than the Year 9 boys. And you can read the sentence. So for B, when both medians are inside, then we cannot claim, there's not enough evidence to claim that there is a significant difference. So while the boys is slightly higher, and we will have mentioned that in our analysis and said that the boys' median is higher than the girls', but over time, if we were to take another sample, it may be that the boys' median is here and the girls' median is here. And we could take another sample and find the boys' median here and the girls' median here. It's just too close to call when you have medians inside each other's boxes. We cannot claim a significant difference back in the populations just based on this one sample, because in fact the medians are within each other's boxes. And of course the tricky situation would be when the median for one of them is on the edge of the box of the other, and the girls' median in this case is inside the boys. So I can see that in another sample the boys' median could be up here, which would make it outside the box, and we would claim a significant difference. Or it could be that with another sample, if that median were to be just slightly less, it would be inside the girls' box, and we'd claim there's no significant difference. So when you get this situation, then it's up to you. You have to make the decision whether to claim a significant difference back in the population or not, and you'll need to use perhaps other statistics to make that claim. And if you pause and read what I've written here, you can see that I've thought about it, and while it is on the edge, there's still 50% of values here above the girls, and in fact over 25%, and I've suggested perhaps as much as 35% of boys' heights there are above the tallest girl. So from this example, I would be happy to claim that back in the population that these sample data came from, that the boys are taller than the girls. But in that situation, it will depend on your argument. So if we try it for our rugby example, clearly the medians lie within each other's boxes because they're exactly the same. So we can't claim that there is a significant difference in the weights of the New Zealand All Blacks and the New Zealand Australians for all the players from this World Cup campaign. So if we just check how we start off, I would claim that there is a significant difference. So in fact what we want is this example here. So if we copy that, go back to the rugby one, paste it there, we want weights, and you can have a read of that and work it out for your example. Of course, if you do claim that there is a significant difference, then it's really important that you state which way that difference goes. So if we go back to our conclusion one and have a look at an example such as this one, where we can claim there is a significant difference back in the population because the median height for girls lies outside the box for the boys' heights. Remember, I would claim that generally Year 9 girls are taller. So as well as saying there is a difference, you then need to clarify that with which way the shift goes. In this case, that Year 9 girls would be taller. That's not necessary when you're claiming no significant difference.